So we're going to go over what's called synthetic division. So it's another way to divide polynomials, and it's not as long as long division. And it's all in this setup, okay? So first of all, you can only use synthetic division if the divisor is linear, meaning you can't have a degree higher than 1 for the divisor. Okay, so just keep that in mind. You have to make sure the divisor is in standard form. So it's got to be in the form like x minus c, okay? Divisor has to be like that. The dividend, that could be, longer, a bigger polynomial, higher degree. That doesn't really matter the degree, but it does have to be in standard form. And if there are any missing terms, you have to put a 0 in for them. Okay, so just like in long division. All right, so now we'll go over the setup. So you're going to take C, whatever makes the divisor 0, or you set this equal to 0. Anyway, you're going to get C. In this case, C is 3. Take that 3 and put it in a box. I guess half a box. But this is how I always do it. Then you're going to pull off the coefficients on your polynomial. Now, if the degree is 3, if the highest degree is 3, or the degree of the polynomial is 3, then you're going to have 4 coefficients. It's always going to be 1 more than the degree of the polynomial. Okay, so what are those coefficients? 1, 4, -5, and 5. Notice that I have them spread apart a little bit because I don't want it to look like a 14. So if I have the 1 and 4 too close together, it's going to look like 14. So I've got to keep those separate. And then leave a little space and you draw a line. That's the setup, and that's half the battle right there. Okay, so you get the setup. The first term always drops straight down. So that's going to be a 1. Then you take the 1 and you go to the box and you're going to multiply. So 1 times 3. 1 times 3 is 3. That goes in the next column. Then you add. 4 and 3 is 7. Now we keep doing that. We always go back to the box. 7 times 3, 21. Goes in the next column. Then you add. Okay, so -5 and 21, that's what, 16? Then you go 16 times 3. Now you don't really have to draw those dotted lines. They're kind of getting in my way, but I want to emphasize you're always going back to the box. You always multiply. 16 times 3 is 48. Okay, and then I'm going to add 5 and 48 is 53. I always put a box around that last number. This is going to be the remainder. Okay? So if the remainder winds up being 0, you know it divided evenly. Okay. So that's a bunch of numbers. It's almost like a trick, It's a little procedure. It's not nearly as much writing as the long division. Okay, but what's the answer? Remember, we're trying to divide these polynomials. Okay, so the answer comes from these numbers right here. Those are going to be the coefficients of your polynomial, of your quotient. And the only thing is you have to go down a degree. So if it was x cubed, now it's going to go to x squared. In fact, that's a 1x squared. That 1's coming from there. You don't have to write the 1, but okay. Then you're just going to go in order. Plus 7x plus 16 plus, and then it's the remainder, so it's 53 over the divisor, x minus 3. That's the answer then. That's the quotient and remainder, okay? But I probably wouldn't put the 1. Okay, so it's a little bit of a trick. Once you get the hang of it, you do about 3 or 4 of these and you're going to be like, oh, these are easy, which is great because we use synthetic division for a bunch of stuff. Okay, so here's another example. So it says use synthetic division. You have x plus 2. Now remember, it has to be x minus c. So in this case, c is -2. -2. Okay, put the c in the box. And now we're going to have to pull off these coefficients. Now, hopefully you're looking at that polynomial and you're saying, oh, something's missing. There's a 0x squared. And it makes a difference where the 0 is. It's got to be in the right order. So now we're going to pull off those coefficients. 5, 0, 6, 8. Now, if you want to stop the video and see if you can do the rest, great. If you don't, I'm going to do it anyway. But all right, the first term comes straight down, 5. Then you go 5 times negative 2, negative 10. Then you add 0 and negative 10 is negative 10. Now you multiply. Negative 10 times negative 2, 20. Add 26. Now what's 26 times negative 2? I think that's negative 52. And then I have to do one more thing. 8 and negative 52. I'll say that's negative 44. Okay, and you could use a calculator if you needed to. Sometimes the numbers get really large, but that's okay. We don't care. The bad news about synthetic division is there's nobody to say whether you did something right or wrong, because those numbers are just going to be whatever you put. It's fairly easy to do. You multiply, add, all the way across the row. Okay, what's the answer? Well, remember we started with an x cubed, but we're going to go down a degree. Why are we going down a degree? Because we're dividing by a linear factor. Okay, so think of dividing everything by x. Okay, so 5x squared minus 10x plus 26. Now, I'm going to put minus 44 over x plus 2. You could put plus a negative 44, that would be fine, but I'm going to put minus 44 over x plus 2. All right, that's synthetic division. If you didn't get the hang of it, don't worry about it because we're going to do it for several more examples. It'll be the work that we do for some of these theorems.